So now we're moving on to the problem lead code 3286, which is find a safe walk through a grid. It is a medium level problem. So we've been given a m×n binary matrix grid and an integer health. So we start at upper left corner 0, 0 and would like to go to the bottom right corner, which is m-1, n -1. You can move up, down, left, right. So 4 directionally we can move from one cell to another adjacent cell as long as the health remains positive. So cells I, j with grid of I, j equal to 1 are considered unsafe and reduce your health by 1. So those grids which have 1 as the value are unsafe and they can reduce your health by 1. Return true if you can reach the final cell with a health value of 1 or more, greater than or equal to 1, and false otherwise. So for this example, we can see that those cells which have been marked by 1 reduce our health by 1, and our health is also given as 1 only. So we basically take this path, all the zeros, we take this path and reach to the bottom right cell, and our health is also not reduced by even a single unit. So we can reach the final cell can be reached safely by walking along the gray cells, which are the cells marked with 0. Now in our next example, we see that our health has been initialized with 3, and if we try to go from this point to this point 0 to 1, we have a decrement of 1, so our health remaining is 2. Then again, if we go from here to here, we have another decrement, so that makes it 1. Then we can go from 0 to 0, 0 to 0. Now there's another 1, and here also there is another 1. So you cannot take any other path to reach the bottom right without having to decrease the health equal to 0. So that means that a minimum of 4 health points is actually required to reach the final cell. That is why it is false, because when we have health equal to 3, we won't be able to reach the final bottom right cell. Now our third example is where health is equal to 5, and we are starting at this point. So here your decrement would be 1 because the initial cell itself is 1. Then here we move another 1, we decremented by another 1. Then we can move here 0 cells, so no decrements. Now we move here, so here also we can have one more decrement, but now we have reached here. So basically we have reached with a value greater than equal to 1. So that means that we can move to it safely by walking through the cells, gray cells, right? So that's the problem. So you basically need to return true or false. So that is why we have a boolean type variable, boolean type function, and we declare a isValid function, which would basically be checking whether the next cell's coordinates, or the neighboring cells that we are moving to, whether they are in bounds of the grid or not. So that basically is returned I greater than equal to 0 and I less than m, and j greater than equal to 0 and j less than n. It would return true, otherwise it would return false. So if the next cell is an obstacle, health is reduced, and if it's not, health remains the same. This is the key concept in the problem, and we will basically be traversing using Dijkstra's algorithm. So we declare a vector of directions of int type, and find safe walk is the function which takes grid and health. M is the number of rows, grid dot size, and n is the grid of 0, 0 dot size, which is the number of columns. We maintain a max heap, which will store the maximum health and the I and j coordinates, or x and y coordinates, which are denoting the row and the column. So we make a priority queue pair of int type, and this is basically, we are not using greater because we are declaring a max heap. A greater is greater is a syntax which is used when we have a minimum heap. So since we have max heap, we don't need that. So this is the priority queue, and visited basically is going to mark the cell, whether the cell has been visited or not. It is m×n again and marked with false. All the initially cells have been marked with false. So we check if the starting point itself is marked with 1, that is, that cell is unsafe, that is, it would decrease the health by -1, right? So if the starting cell is itself, in this case as well, the starting cell was 1, so we had to start with health equal to health minus 1, right? So the top left cell itself is an obstacle, that means, so we push the health -1 and the coordinates 0, 0. Otherwise, if it is 0, then we push the normal, the initial health value without decreasing it, right? And we mark the grid 0, 0, width of 0, 0 as 2. Now we start the algorithm, that is, while the priority queue is not empty, we get the current element from the priority queue and pop it out, and we initialize the 3 values that we have: current health, x and y coordinates, right? So that is extracted from current dot first, because this is the current dot first, and current dot second, that is this, and current dot second ka first would be row, and current dot second ka second would be the y coordinate, that is the column, right? So we now check if x is equal to -1 and y is equal to n minus 1. That is, if we have already reached the bottom right cell, we check if our current health is greater than equal to 1. That is, we are reaching safely to the bottom right cell with a value of greater than equal to 1. That is basically given to us in the problem statement, that we need to reach it with a health value of greater than equal to 1. So if this is happening, then we return true. So this is the problem statement that has been given to us. And now this is a check that we had to do. Now we can go over each of the direction, that is the 4 directions: top, left, right, and down. So the next cell x coordinates is nx, and next cell's y coordinate is ny, and we add x plus d of 0 and a y plus d of 1. So we check if this is valid, that is, if this cell that we are moving to nx and y is within bounds of the grid and it has not yet been visited. Then we check if the grid uh, nx and y is equal to 0, that is, if the value of the grid is 0, that is, it is not an obstacle, so there would be no decrement in health. Then we mark the visitor of that cell as true, that is, it has been visited, and we push current health as it is, that is, we are not decrementing the health. Otherwise, if it is equal to 1, we decrement the health and we push current health minus 1 and we visit it. And finally, we return false if we are coming out of the loop without this statement hitting. And let me just submit it and show you. So yes, it has been accepted, and that's it about the video.